Good morning, students. Welcome to ABN and PRR College online classes. Now let us consider another application of sandwich theorem. Very important is that let us discuss the nature of the sequences of the form r power n when r is in between +1 and -1 and equal to 1. ఇలాంటి సీక్వెన్సెస్ ఇచ్చినప్పుడు మనం కేసెస్లో రన్ చేయాలండి. బికాజ్ ఆర్ వాల్యూ అనేది ఇన్ బిట్వీన్ ఇచ్చినప్పుడు లెట్ us టేక్ ద రైట్ లైన్, రియల్ లైన్ని కన్సిడర్ చేసినట్లయితే ఇన్ బిట్వీన్ 0 and 1 ఉన్నప్పుడు ఆర్ వాల్యూ కేస్ 1 కింద కన్సిడర్ చేద్దాం. అండ్ వెన్ ఆర్ వాల్యూ ఈజ్ ఇన్ బిట్వీన్ -1 and 0 it is the second case, and r equal to 0 this is the third case, and r equal to 1 this is the fourth case. In each and every case let us observe the nature of given sequence, whether it is convergent or not. Coming to the case 1, if the value of r is in between 1 and 0, in this case let us take the value of t is a positive real number such that r can be written as 1 by 1 plus t. If we take the value of r is like this, obviously the value of r is in between 0 and 1 by giving the values of t. Suppose if you give the value of t as 1, this value is 1 by 1 plus 1, that is 1 by 2 is 0.5. It is in between 0 and 1. By raising the values of t, obviously the value of r is approaching to 0. That means totally the value of r is in between 0 and 1. Now take the value r power n. Raising the powers on both sides up to n, we get like this. This is equal to 1 by 1 plus t whole power n. Let us write the denominator expansion by using binomial theorem. We know that actually 1 plus t whole power n is equal to nc naught into t power 0 plus nc1 into t plus nc2 into t square plus and so on ncn into t power n. This can be written as nc naught value is 1 plus nc1 means n into t plus nc2 means n into n minus 1 into by 2 factorial into t square plus and so on ncn means 1 into t power n. This is the value, denominator value, by using the binomial expansion. Now let us take the relation of above expression and the value 1 plus nt. On observation in the above expression the value is added. Now we have taken only 2 terms. Which one is the biggest one? Obviously above expression is the biggest one. This value is more than 1 plus nt. Some more terms are added here. Let us write these values in r power n. Therefore r power n is equal to 1 by 1 plus t whole power n means 1 plus n into t plus n into n minus 1 by 2 factorial into t square plus and so on t power n. Whenever this value is lesser than this one from this, so this is take as x is greater than 1 plus nt, write it in reciprocal notation, then 1 by x is less than 1 by 1 plus nt. So this value is now write this value as 1 by 1 plus nt. By using this notation we can write the relation as lesser than. Now taking minus 1 on this equation, 1 by nt. 1 plus nt is obviously more than nt, you know that. By reciprocally, 1 plus 1 by nt, 1 by 1 plus nt value is less than 1 by nt. From this, write the relation here. What is this value? Is lesser than 1 by nt. So this value is lesser than 1 by nt. That means r power n value is less than 1 by nt. We have the value of r is in this case is in between 0 and 1. Whenever r is positive, obviously r power n is positive. That means r power n is positive. That is, our r power n is now lies in between 1 by nt and 0. What is r power n? We have taken here Sn. Sn is in between 0 and 1 by nt. Now apply sandwich theorem. Let Tn is equal to 0 and Un is equal to 1 by nt. You know that when n tends to infinity, Tn limit is 0 because 0 limit is 0, it is constant. Here also limit of Un when n tends to infinity is equal to limit of 1 by nt. By taking outside of t, then limit of 1 by n when n tends to infinity is 0. 0 into 1 by t is 0. That means we observe that Tn and Un converges to same limit 0, then Sn is also converges to 0. Then by sandwich theorem we can confirm that limit of Sn is also 0. That is, what is Sn? R power n limit is 0. When we get a finite quantity as a limit, then we can confirm that r power n is convergent. When r is in between 0 and 1. Now coming to the case 2. If r is in between 0 and minus 1, in this section 0 and minus 1, let us take r value as minus k, where k is a positive real number. Then from the above inequality, minus 1 is less than minus k is less than 0. Taking negative sign on both sides, we get the relation as reversed. That is, 0 is less than k is less than 1. Therefore, from case 1, by using case 1, whenever the value of any real number is in between 0 and 1, limit of k power n when n tends to infinity. In this case, we proved that this value is 0. What is k? Minus r. Whenever r value is minus k, then k value is minus r is equal to 0. We can write it as limit of minus 1 whole power n into r power n and n tending to infinity. Here also our sequence r power n is convergent when r is in between 0 and minus 1. Coming to the third and fourth cases, they are very simple. Case 3, if r is equal to 0, then r power n is 0, limit of r power n is also 0, because 0 limit is 0. In this case, our sequence is convergent. Coming to the case 4, If r is equal to 1, then r power n is again 1. Limit of r power n is limit of 1 when n tends to infinity. Constant limit is same constant. We obtain the limit as finite quantity, therefore r power n is converges to 1. That means from among these 4 cases, we confirmed that in each and every cases, we confirmed that in 3 cases we have our sequence r power n is converges to 0 and r power n is converges to 1 in the 4th case, which means that whenever r is in between 1 and minus 1, r power n, the geometric sequence is convergent. This is the conclusion of given sequence. Okay, thank you.